Find the product of last two digits of this number 1919 raised to 1919. Now, in JEE Main, there are few PYQ where you need the digit at unit place or the digit at 10th place of a raised to b, where a and b, those are two integers. So in these type of problem, basically we have to create zeros here, right? We can write this, the given number is 19 raised to 1919. Now, this you can write as -1 plus 1920 raised to 1919. And then using binomial, you can easily find the digit at unit place or the digit at 10th place and so on. Also, sometimes the problem will be find the digit at unit place only. So in that case, you can use cyclicity also, right? If I need only the digit at unit place, then without using binomial also you can answer that. First of all, digit at unit place will be decided by this 9 only. The other digits, they are irrelevant. And if you see the different exponents of 9, so 9 raised to 1 will be 9. For 9 squared, the digit at unit place will be 1. For 9 cube, the digit at unit place is 9. 9 raised to 4, the digit at unit place is again 1 and so on. So for 9, this is the pattern you are getting 9, 1, 9, 1 and so on. Whenever exponent is even number, the digit at unit place will be 1. Whenever the exponent is odd number, the digit at unit place will be 9. So that means in this number, the digit at unit place, because the exponent is an odd number, the digit at unit place will be 9, right? So at unit place, we have to get 9. But because the problem is we need the last two digits, in fact, product of last two digits. If options were there, then only those options which are multiple of 9, that should be the valid option, right? But here, because it was integer type, so we have to use binomial. And then we have to see what should be the digit at 10th place. At unit place, we'll definitely get 9 because the exponent is odd number. Now here if I expand it using binomial, then -1 raised to odd power, that will be -1. Next term will be 19c, 1919c1, and this multiplied by 1920. After that, again, next term will have minus sign, right? Because of the negative sign, we'll get alternate positive, negative terms and so on. First term was negative because we had -1 raised to odd power. Next will be positive, again negative and so on. Now in next time you can see that you will get a square of this one, 1920 square, and in 1920 we have 1 0, so its square will have two zeros, right? That means the next number is definitely multiple of 100, right? After that, next number will have cube of this one, so that will be 100 into some integer. So you can combine all of those numbers and you can say that all the numbers after all the terms after this second term, they are multiples of 100. Now we do not, because if the number is multiple of 100, then it will not contribute to the digit at unit place or the 10th place, right? So therefore we can combine all of those numbers and we can say that it is some multiple of 100, because we are interested in only the last two digits. So we can write rest of the numbers in this form. And now we have -1 plus 1919, and this multiplied by 1920 plus 100k. Now here also, if you want, you can save some time and you can write this number as uh, maybe 100k we can write first, and then this number you can write as 1900 plus 19, right? And the other number you can write as 1900 plus 20 and then -1. Why we are writing in this form? Because when you multiply these two, you will get four terms, and only 19 into 20, this is not multiple of 100. All the other numbers, they will be multiple of 100, right? So in fact, you can combine this one and you can say that we have 100k and all of these numbers, for example, 1900 into 1900, so that is multiple of 100. 1900 into 20, that is also multiple of 100. So all of these numbers, that will be multiple of 100. 19 into 20 will be 380, and 380 minus 1, so we have 389. Now again, this 3 you can adjust with 100k, so finally the number is of this form, right? Finally the number n, this will be some multiple of 100, and the last two digits, in fact, will get 80 minus 1, so this will be 79, right? Multiple of 100, and then 380 minus 1, so that is 379. 300 we can write with multiple of 100. So finally this is the number, some multiple of 100 plus 79. So the digit at unit place is definitely 9, that we had seen earlier, we had established earlier also. And at 10th place, we are going to get 7. Now the problem is we need the product of digit at unit place and 10th place. So 9 into 7, 63. That is the correct answer for this problem. So in this type of problem, all we have to do is break this number as minus 1 plus 1920 and then use binomial theorem. All of these numbers, they are multiple of 100 and therefore they will not contribute to the digit at unit place or 10th place. Finally, the number was multiple of 100 plus 79. So at unit place we have 9, at 10th place we have 7. The product of last two digits, that will be 63, and that is the correct answer for this problem.